So building off what we did yesterday, here's our bell work. We're trying to figure out where f has a relative minimum. If I want to know when f has a relative minimum, we need to find critical points and endpoints. There aren't any endpoints. We're going to look at critical points. What do I do to find critical points? Set the derivative equal to 0. So here is my derivative. What numbers? Show me with your fingers. How many critical points, how many critical numbers am I going to put on this number line? There are 3. This is going to get me 0. This is going to get me 3. This is going to get me -1. I just take each of them, set it equal to 0, and solve. So -1 should come first, and then 0, and then 3. Everybody good to that point? Now we're going to plug in some numbers. Somebody pick me a number to plug in. 1. If I plug in 1, that will fall in between 0 and 3. Okay? If I plug in 1 for x, is it going to be positive or negative? Positive. If I plug in 1 for x here, is it going to be... Ooh, 1 minus 3 is -2, but I'm squaring it. What number could I plug into x minus 3 squared and not get positive? It's really just anything, right? Because I'm squaring it. If I take a positive number and I square it, it's positive. If I take a negative number and I square it, it's positive. So this is a question that is on the AP exam every year. It is often missed, and it is so easy in terms of looking at this. When you look at this problem and you see that that is squared, just disregard it, okay? Because it's not going to change signs. That's not really going to matter at all. Because no matter if I plug in a number that's above it or below it, it's not going to change. Okay, so I just don't look at it because it doesn't matter, because when I square it, it's always going to be positive. So a positive number, I'm plugging in 1. What happens? 1 plus 1, what's that going to give me? 2. It's positive. Okay, so if I plugged in 1, I would get a positive number. I'm going to keep going from there. I plugged in 1. I need another number. What other number am I plugging in? -2. If I plug in a -2 here, it's going to be negative. -2 here, it's going to be negative. What's a negative times a negative? Positive. What other number should I plug in? -1/2. If I plug in a -1/2 here, it's negative. -1/2 here, it's going to be positive. A negative times a positive is negative. And then last one, I'm plugging in a number bigger than 3, like 10 billion. 10 billion is positive. 10 billion plus 1 is positive. It's positive. There is my sign chart. Okay, that's not tough to do. I found the zeros, and then I plugged in some numbers. Show me with your fingers. Based off of that sign chart, where does F have a relative minimum? A, B, C, D, or E. Where does that have a relative minimum? The answer is B. Okay, let's do it. Let's just look at it. Before -1, F prime, before -1, F prime is positive. Show me with your arm, what does F prime positive look like? That means positive slope. And then after it, from -1 to 0, F prime is negative. So what does that mean? Going down. After 0, it's positive. So then what does that mean? Going back up. After 3, it's also positive. So now what am I going to do? Still going up. So 3, so we said 0 is our minimum. What's -1? -1 is going to be my maximum. What's 3 going to be? It's nothing. What's actually happening here is the slope is 0 and then it goes back up again, but it's not a max or a min. Okay, it's neither there at 3. It's not a max or a min. And I can tell that very early on. When I look at this problem initially, when that x minus 3 is squared, I know it's not going to be a max or a min, because in order to be a max or min, your sign has to change. And if it's squared, or it's to the 4th power, or the 6th power, the sign is not going to change. Make sense on what we're doing there? All right, let's finish these notes from yesterday. I want to get through them fairly quickly. I don't want to wait forever. I know it's the last day before break. You don't have a bunch of brain power left. Okay, put your bell works in front. I'll collect those here in a second. We are finding the extreme values. Okay, to find extreme values, where do extrema happen? Endpoints and critical points. I got endpoints. Here are the endpoints, 1 and 4. Now I want to find critical points. Where do critical points happen? Where what equals 0? The slope, the derivative is 0 or undefined. Derivative is 0 undefined. So let's do that real quick. Find your derivative. Take a second with your neighbor. Find your derivative here. Here we go. We're finding the derivative. Jalen, what's the derivative of 2x going to get me? 2. What about the derivative of negative 8 natural log of x? Yep, negative 8 times 1 over x, because the derivative of natural log is 1 over x, or simply negative 8 over x is probably the cleanest way to write that. That is my derivative. The first thing I'm doing is thinking, can this thing be undefined? Yeah, pretty easily. What would I have to plug in for x to make this thing undefined? 0. So I have a critical number at x is equal to 0, because if I plug in 0 right there, it's going to be undefined. The other thing I got to see is it going to be equal to 0? Well, let's solve it. You should be able to pick a number out here, but if you can't do it, we solve it. So I'm going to just add this over. 2 is equal to 8 divided by what? 4. The missing number is 4. You could get into fancy solving, like we could multiply both sides by x, and then 2x is equal to 8, and then divide by 2, divide by 2. X is 4. Okay? But these are my critical numbers, no matter how you got them. Okay? These are my critical numbers, 0 and 4. Yes, sir? Yeah, because if I plugged in 0 for x, it's 0's in the denominator. That makes it undefined. Everybody okay with how I found my critical numbers? So I'm going to make a sign chart. Now, careful with this question. Talk with your neighbor for a second. How many different numbers am I putting on my sign chart? How many different numbers am I putting on this sign chart? Show me with your fingers. How many different numbers am I putting on this sign chart? I see no right answers. Oh, Aaron's got a right answer. There we go. We got a couple in there. 1 and 4. Those are my endpoints. So it's a cat number line, 1 and 4. Is 0 going to go on this sign chart? No, it's too small. Would I really need to write 4 again? No. It's just 1 and 4. A dumb question, but a question nonetheless. I asked it, so you got to listen to me. Okay, cool. We've got that. Now I just need to find signs. What's a good number to plug in? 2. If I plug in 2, it would be 2 minus 8 over 2. So 2 minus 4, positive or negative? Negative. Make a decision. At 1, talk with your neighbor, is 1 going to be a maximum or a minimum? Talk with your neighbor. Is 1 going to be a maximum or a minimum? Thumbs up if you think 1 is a maximum. Thumbs down if you think 1 is a minimum. Thumbs up if you think it's a maximum. All right, we're not sure. It is a maximum. Michael, why do you think 1's going to be a maximum? What does f prime negative mean? I have negative slope. So draw something with negative slope. What is this side over here if I have negative slope after it? It's a maximum. What is 4 going to be then if it's at the end of something with negative slope? It's a minimum. It's just understanding what f prime is negative means. F prime is negative means it has negative slope. Everybody somewhat okay there? All right, let's go to the next page. We kind of just talked about this in bell work. Let's do it quickly. I'm not going to mess around here with making you do it in a long, drawn-out fashion. F prime of x, we're finding extreme values. So endpoints and critical points. There's no endpoints, so we're going to find critical points. That means I got to find the derivative. Macy, what's my derivative going to be here? Yep. That's it. 3x squared, that's it. Is that thing ever going to be undefined? No. So I'm going to set it equal to 0 and solve. What's my x value going to be? 0. Make a sign chart real quick. Fill in your sign chart. Go. I made my sign chart. 0 was the only number that is going to make this thing equal to 0, because 0 squared times 3 is going to get me 0. What's a number less than 0 to plug in? -1. If I plug -1 in right there, -1 squared, positive times, oh, it's positive. What's a number bigger than 0? 1. If I plug in 1, I'm going to get, positive. Remember, I'm plugging into the derivative. So what is 0? Is 0 a max or a min? Neither. Let's understand why. X cubed plus 2. Show me with your arms. What does x cubed look like? X cubed. You guys all just showed me x squared. It's not a parabola. That's x squared. X cubed is this guy. The plus 2 moves me up 2. So I'm going to try to draw this accurately. I'm going to zoom in. Maybe. Nope. There we go. Up 2 because of that plus 1, and then it's this. What's happening here is I'm increasing. For a moment in time there, my slope is 0. Okay, that cubic function, it's 0, but then it's increasing again. That's what happened. The slope right here is 0. That's what we found out. Is that point right there, is that a max or a min? It's neither one. It's not a max or a min. Just because it's a critical number doesn't mean it has to be a max or a min. It could be, doesn't have to. What that ends up being is called an inflection point, but we're not even ready for that yet. We'll get that later on. Questions there? All right, let's do this one. Example 6. A particle is moving along the x-axis with this as its velocity on the interval from 0 to 5. Our job is to find the maximum velocity. They gave me velocity. I want to know the maximum of that. What do I do to find maximums? I'm going to take the derivative. I got endpoints, so I'm going to check some endpoints as well. But the other thing I'm going to do is I'm going to take the derivative. So find what v prime of t is, and then figure out what the critical numbers are. Go. We are finding critical numbers. We got endpoints. Now we got to find critical numbers. So we got to find the derivative. Jacob, what's your derivative going to be here? Yes, sir. 2t minus 6. Took the derivative of that. We take the derivative. Then we're going to decide if it's 0 or undefined. Is it ever going to be undefined? No fraction. So make it equal to 0. 2t equals 6. So t equals 3. That is a critical number. Okay, that's an endpoint. That's a critical number. So both of those things are going to go on my sign chart. This is a v prime sign chart, also known as acceleration. It's a capped sign chart since I'm going from 0 to 5. And the only other number I'm plugging on there is 3. What's a good number to plug in? 1. What am I plugging 1 into? The derivative. I'm plugging it in right here. Not right there. Not into the 0 part. Just this part. 2 minus 6, that's negative. Plug a number like 4 in. 8 minus 6, that's positive. So at 3, thumbs down up if 3 is a maximum. Thumbs down if 3 is a minimum. 3 is a minimum. Okay? It's going negative slope, positive slope. So where are the maximums happening here? At 0 and 5. Both of those are maximums. Look at that graph. This is a max. And that's a max. They're both maximums here. It's like you have 2 maxes in one class. Okay? They're both maximums in this case. Got you. That's it. Yeah. That was nice. Okay? It is a maximum because of how the graph works. Now that's a little bit, that's not the answer to this question. Okay? That's different than what the question is asking. The question that's being asked is find the maximum velocity. Okay? If I said, what was the maximum speed you had in your car? You wouldn't tell me it was in front of the high school. Right? That's not answering the question. That's where it happened. The question is, what is your maximum velocity? What is your maximum speed? So what do I need to do to find what the maximum velocity was? Plug it in. Plug in 0 and 5. What am I going to plug it into? Velocity or into the derivative? Velocity, because I want to know the maximum velocity. And so I'm going to find v of 0. If I plug in 0, what do I get? Quattro. and then I'm going to plug in 5. If I plug in 5, I get -1. So the question was, find the maximum velocity. What is the maximum velocity here? The answer is 4, because that is what the velocity was. When did it happen? When t was equal to 0. But what was the maximum velocity? It was 4. Because it's biggest. It's the biggest number that I got. You can plug in any number you want between 0 and 5. The biggest number you're going to get for this equation is 4. That's what we just found out. All right, we're going to skip 7. Let's just look at it. I'm not going to make you write anything down. Okay? This is a position equation. That's a position equation. You are trying to find maximum velocity. Talk with your neighbor. You don't have to write anything down. What is our attack plan going to be here? If they gave me position and I want to find maximum velocity, talk to each other. All right. Anybody have a good answer here? If I'm finding maximum velocity and they gave me position. Lulu, what do you think? You got to take the second derivative. You would have to find velocity first, which is 3t squared minus 12t plus 50, which is great. That's velocity. But I want to know the maximum of velocity. And if I want to know the maximum of something, I need to take its derivative. So I need to find velocity, then find its derivative, and do everything we did on the last problem. So now it's just the last problem. We just had to find the derivative first. Make sense on that? Let's go to the backside. A function. Okay, and I'm going to say a function, f of x. When I say a function here, I did a bad job. I should have said a function, f of x, is increasing if f prime of x is, if f is increasing. Imagine a graph that's increasing. What is going to be true about f prime? It's positive. It's greater than 0. It's got to be positive. If f prime is positive, that means the slope is positive. If the slope is positive, that means it's increasing. A function is decreasing, means f prime is negative. This is an important concept, okay? This is something we're going to do all of the time. You got to be good at it. And this is our first real example with it. We're going to do it all the time. This is a graph. From here on out, every time you look at a graph, you need to be very specific as to what it is. It says right here, this is a graph of f prime. When you read that, I would suggest if you have a highlighter, you would highlight it. Or in other words, at least rewrite f prime and throw a box around it. Okay? Redraw it real big. I know it's there, but write it again anyways. That way your mind changes gears. That is a graph of f prime. We are trying to figure out where the function, and I should have written this, but where the function f of x, not f prime of x, but where is f of x increasing? And where is f of x decreasing? It should be an interval. Talk with your neighbor. See if you can answer those two questions. Confident in where they think the function f of x is increasing. Fatimata, what do you think? Wonderful. -6 to -2 and 2 to 5. Anytime we talk about the first derivative, we're going to use brackets. Okay? Why, Fatimata, did you pick -6 to -2 and from 2 to 5? Perfect answer. This is a graph of f prime. F is increasing, means f prime is positive. So she looked on this graph. When is this graph above the x-axis? That is from -6 to -2 and from 2 until 5. So where is this function decreasing? -2 to -2. Why is it decreasing from -2 to -2? Yeah, whatever. Yeah. My bad. -2 to 2. Because f prime of x is negative. Make sense the difference there? All right, last thing here. Let's do it really fast. The local extrema. So we're using analytical methods. So it means use some algebra and some calculus to find the local extrema and the intervals on which the function is increasing and decreasing. This is zero more work than what we've done so far. It's exactly the same. We're just going to pull more conclusions at the end. Okay? So if I want to find extrema, maxes and mins, what do I want to do with this thing to find maxes and mins? Derivative f prime of x is going to be equal to 2x minus 1. Find the critical points. Make a sign chart. Go. All right, we took the derivative. We set it equal to 0. We solved. Show me the fingers. Where is your critical number going to be? A half. And 1. Divide by 2. X equals 1/2. That is my critical number. So sign chart it. F prime. What's the only thing that's going on in this sign chart? 1/2 is the only thing I got. There's no there's no other critical numbers. There's no endpoints. Pick a number bigger than 1/2, like a bajillion. If I plug in a bajillion here, is it going to be positive or negative? Positive. If I plug in negative bajillion, is it going to be positive or negative? Negative. You can pick whatever you want. 0 might be easier, but I just like getting crazy. Here we go. 1/2. Show me at 1/2. Thumbs up if you think 1/2 is a maximum. Show me thumbs down if you think 1/2 is a minimum. 1/2 is going to be a minimum. Alana, why do you think 1/2 is going to be a minimum? Decreasing to increasing. F changes from decreasing to increasing. You could also say F prime changes from negative to positive. Either one. I would say F prime just because that's what they gave me, but I'm in total agreement with what you said there. Wonderful. That's the minimum. Now it does go on and ask you, when is the function increasing and decreasing? This is super easy. All you have to do is translate this. Okay? So F is increasing and F is decreasing. When is F going to be increasing on this graph? When F prime is, when F prime is positive, it's increasing. So 1/2 to infinity. Bracket, always parenthesis on infinity. When is it decreasing? Negative infinity till 1/2, because F prime is negative. Boom, done. That's no different than what we did before. It's just translating it into some different language. Make sense there? You guys want homework? Me neither. So let's just do some stuff together here. Okay? I'm just going to put something on the board. I'm going to ask for your feedback. So stick with me here. This is a graph of F prime. This is a graph of F prime. Talk with your neighbor. How many maximums does this graph have? We're assuming that it is not capped. Assume that that graph continues on either direction. Talk with your neighbor. Decide how many maximums does this graph have? Does F have? This is a graph of F prime. How many maximums does F have? Show me with your fingers. How many maximums do you think this graph has? The answer is 1. The answer is 1. Where is that maximum happening? It's at 9. It's a graph of F prime. You got it. You can't look at the graph and look at the highest points. That's not what it's asking at all. This is a graph of F prime. That tells you the slope of F. What has to happen with F prime for you to have a maximum? F prime has to change from positive to negative. That's what makes a maximum. So, what is happening at 0? That's a minimum because F prime is changing from negative, being below the x-axis, to being above the x-axis. That makes that a minimum. What's happening at 5? Is 5 a maximum or a minimum? It's neither, because it's not doing anything. It's going from positive to more positive again. 9, F prime is changing from positive to negative. That makes that a max. That's weird. We are going to spend a ton of more time on that. Don't let that be weird to you yet. If you're struggling with that, you'll be fine. Let's do another one. That's a graph of F prime. Find where the minimum occurs. Find where you think the minimum occurs. Show me with your fingers at what x value is the minimum going to occur. It's at 0. How do we know that? What is happening on this graph that tells you that it's going to f is going to have a minimum at 0? Jacob, what do you think? I like it except for how you started it. Don't say it. What changed from negative to positive? F prime. Good. That you have to say f prime. You cannot say it. You cannot say the graph. You got to call it by the function's name. F prime changes from negative to positive. That's what makes that a minimum. Let me go to this page and then let that load, and then I'm gonna click on this guy right here. Looking at that sign chart is a sign chart F prime. It is a capped sign chart. With your neighbor, figure out how many maximums is this graph going to have. How many maximums do you think there's going to be? Seeing a lot of ones, and then we recycled and went to 2. Let's just do it. The best way to do it is just draw a picture. F prime is positive after -1. So what does that mean I'm doing if it's positive? I'm going up. Then at 0, F prime changed to negative. So now what am I doing? Going down. After 3, it's positive. So now what? Going up. Now what am I going to do? Go up some more. It like flattened out there for a second. That's what's happening there. I'm going down. I'm going up. I'm getting flat, and then I'm going up again. But I'm still going up. And then what's happening at 7? Stopping. So where is there a maximum? This is a max. But where else can maximums happen? At endpoints. This is also a max. This is a min. This is a min. What is 5 going to be? Nothing. Nothing there. Good? One more. Last question of the day. Last question for the next 3 weeks. 2 weeks. Don't get your hopes up. I bet. Let's get it. F prime. Looking at that number line right there. Determine how many extrema does this graph have? How many extrema does it have? Talk with your neighbor. Show me with your finger how many extrema does this graph have? The answer is 2. Are there any endpoints on this graph? No, there's not. So it's going to start up. It's going to start up here. It's going to come down. Oh, just playing. Don't listen to me. It's going to go up because F prime is positive. Then it's going to go down. And then it's going to go up. And then it's going to go up some more. And it's going to keep going. If it doesn't end, then we can't count endpoints. But this is a max. And this is a min. And 5 is nada. Okay, so there is 2 extrema. Make sense of what we're saying there?